Okay, this is the activity with the name characterization of an AB class amplifier. In this activity, there is to set up an electronic circuit. Here we have its draft that works as an amplifier. Here we have the signal we want to amplify. This is the source of the signal. Here we have the amplified signal. This is the load on we put the output signal on, and this is the circuit with the components that perform that function. The nodes for this activity are self-contained. There is no need to explain anything further. Anyway, apart from setting up and measuring in a real circuit this amplifier, there is to simulate it so that we can check on the physical circuit that the values we measure correspond to what we expected. And we will simulate this circuit using the software called ISIS. The software called ISIS, as we can see, I have put all the components I want to set up in a physical circuit, but on this screen. Here we have, this is exactly the same circuit as we have on the nodes of the activity. We put at the input of this circuit a signal with the parameters we need. Here, with right click on this component, on this device, and click left on edit properties, we can see that the properties of this input signal, the amplitude, the frequency or timing, and the phase are set in a desired way. And here we have the rest of the components that will simulate the function of the physical circuit. These two components, this transistor, this one and this one, are not exactly the same model as in the nodes, because this software doesn't contain a model in its libraries that perform the way of working of the devices on the node. But these two devices, 135, 136, were exactly in the same way as the devices 137 and 138 we have on the nodes of the activity. What the most important details I have to make clear are the way of showing the simulations of the signals in this circuit. First of all, the first of these simulations is a time simulation in which we want to see the evolution of the value of voltage and current in some points of the sequence along a certain amount of time. So here we have, in order to simulate the evolution of signals with time, you have to choose on the left panel the option named graph mode. And in graph mode, we have to choose the analog graph. The one we have here is an analog graph I previously configured, and we are going to see which are the parameters I have to change in order to perform an appropriate simulation. So this is the same as a screen of a time graph in which we can see. I'm going to maximize it. We can see the evolution of some signals along the time. This graph, this analog graph, the properties with the right click anyway on the screen, I have to change are the start time of the simulations, stop time of the simulations, and essentially nothing else. After that, I have to choose which signals I want to show on this graph. That's the option add traces. Add traces I can see all the signals that have been marked or named on the circuit, and I chose them. For instance, the signal, the point at the input of the circuit, I have named it as in, and the point at the output of the circuit, I have marked it as out. So if I choose one of the signals, for instance this one, and then I say OK, one new track has been added here. When I simulate the circuit, I will be able to see the evolution of the signal with time. Here we have a previous simulation. If I want to erase the data of the previous simulation, I just have to choose again, right-click anyway on the screen, here graph data. And I want to see the results with the new simulation. The simulation here is exactly the same as the one I had before, but with another signals. I have to choose simulate graph. And here we can see on the screen the values of the signal as time passes. In the x-axis we can see the time, and on the vertical axis we can see the value of the voltage in this case, because the signals are voltage, and current we can see is very small, this value, as time passes. And this is about the simulation of around the time of the values of some signals. I'm going to restore the size of this window, and I will see another type of simulation very interesting also for completing what it's asked in the notes of this activity. Is the simulation with frequency. In order to perform a frequency simulation, we have to choose again of the left panel the option graph mode, and in the graph mode we have to choose this time the option frequency. Okay, if we can see something like a pencil on the screen. If I mark it, here I can set the size of a new simulation of the type frequency. Anyway, I'm going to erase it because I have it here from the previous simulation. This is a simulation of the frequency response I set. Again, as in the previous graph, the previous graph was the analog graph. I have to edit the properties of this graph. The properties of this graph. Again, right-click on the screen. I can see these are the lowest frequency and the highest frequency I want to see simulated on the screen. Here I can choose the distance in frequency from one mark to another mark, or vertical marks. This time I chose in the case as the distance between marks, although I could choose also octaves or linear anyway. The most frequent is the case. If I think this is appropriate, I click left click OK, and in the same way as before, I have to add traces. It is lines that represent the evolution of the signal I choose, in this case with the changing frequency. Okay, I'm going to escape. I'm going to maximize it to see it, and we can see we have a graph. This is the previous graph again, where we can see the value of the output as the frequency changes. There is one parameter I didn't talk before. I will edit graph, and this is the reference value I'm going to compare with the trace I'm going to show on the screen. I mean, there is a signal, this time the signal with label like in the circuit, that is going to suffer the changes of the frequency as I said here. And when this is set, the rest of the signals change their value, the frequency value, as the frequency value of this reference signal changes. So I can show on the screen the value of any signal I want. I could also, here I have traces, I could also put as a new trace also the signal in, but it has no sense because it's always the same time. In amplitude it's always the same time. But the rest of the signals may change their their amplitude as the frequency of the reference signal. This time the signaling changes. Again, as before, I'm going to cancel this. I'm going to clear the data of the previous graph. I could add the tracing I would like. I will not do any. I will not add anyone else. And after that, I can simulate graph. When I simulate graph, I see that the value labeled as salida changes its amplitude as the frequency of the reference labeled as in changes. So at lowest frequency we can see lowest amplitude. At highest frequency we can see again lowest amplitude, and in the middle of this frequency range we can see that the amplitude is more or less constant.